Green Jobs. I'm Abhinav Shukla. So we are doing training on behalf of Skill India Mission in general, and as introduced by the authority here, um, that I am not only an installer, I'm doing training as well. So I have an experience of somewhere around 15 years now in solar photovoltaic, and I have started my career as a research scholar in solar tracking system. Developed a heliostat, then axis tracker, then I've invested my some of the years in vertical axis wind turbine. But I found that the solar photovoltaic is the most convincing business opportunity for anyone in the world. I would say rather now. So when I was doing this thing, the installation work and going on the field and training the people, those who don't know anything about the solar photovoltaic, and they are good with the electricity. So they know how to install the electrical panels, how to install transformers, how to lay the cables, but they don't have any idea about the solar photovoltaic. So I found that it's a desperate need of training programs in solar photovoltaic. And fortunately, in 2014, uh, in NSDC, there are many skill councils, and uh, in electronics skill council, there was a small department which was known as the solar photovoltaic and all. But after that, it is just because of our prime minister, they have initiated this step that they separated the entire SSC for the green jobs. So now there is a full-fledged, dedicated renewable energy skill council in our country, and we are doing the certification on behalf of skill Ministry of Skill Development. So let me start my presentation because I have seen what you have studied till now. So if you have any questions or if you want to, it's my request because I'm not very good with this uh, online training, pattern. I have done only 5, 6 training programs like this, but I have an experience of face-to-face meetings and face-to-face training programs. In that, I can say that I can do better, but I request your attention. I request your participation in this training program. Then only I can deliver the knowledge, and you can learn out of it. So that is my request, that you keep your pen paper with you, and if we discuss anything during this training of 1.5 hour, we will try to exchange our doubts or thoughts, or if you want to clear something from me, so I'll try my level best to do this thing. Okay, so I have seen that you went through with the Sustainable Development Goals, India's mission on climate protection, and then green energy technology. So you are now aware about the basic concepts behind the solar energy. Maybe they have covered the solar thermal as well, apart from solar photovoltaic. So about the solar photovoltaic, you are now having experience. I don't know how you have done a hands-on or practical case study, but yes, now you are aware about the components of grid-connected solar photovoltaic plants and the metering arrangement, net metering, gross metering, virtual net metering, and the captive group metering. So yes, this is you have done. You know about the RESCO and the CAPEX model, the business models what we are having in general. But these days there are some other models as well. It's okay for a first time. This is sufficient for about the business models, government regulation schemes, and then the about the software. So I don't know how somebody can. Okay, Nikhil has taken. He's my one of the very good friend. In 1.5 hours, he has done three. He present three softwares. Okay, it's okay. Now it's my turn. Uh, National policy regulatory framework for solar photovoltaic rooftop mainly. So you have seen here, it is clearly mentioned that it is only concerned with the rooftop. So if you have any questions regarding, my presentation or any of the doubt, you can ask. But you have to keep yourself within the limits of solar rooftop, because ground mounted is something entirely different. If you see the regulatory framework and the way of evacuation of power. So now let us go with the presentation. Am I audible and you can see my this my screen, my presentation? Are you able to? Okay. Yes.
Yes, you
No.
are, and slides are visible.
Okay. Thank you. Okay. Okay. So my in this session, my first thing what I would like to share with you, why solar is an alternative of source of energy, and what are the new things in phase two policy what we are having now in from Ministry and new renewable energy. So here the most important thing you should understand before teaching or doing the solar business, that what is the real potential of this solar energy. I think many of the things are already discussed, but let me start with this question. Say, what is the difference between a fuel-based electricity generation and the technology-based electricity generation? This is the key thing behind a success of a alternative source of, what do you say, the solar photovoltaic or any of the thing. Anybody has any idea? If anybody would like to say something on it, what is the difference between a technology-based electricity generation like solar and a fuel-based technology? What is the difference? Can anybody add something? You can unmute yourself. See, I don't want to be a one-sided training program. I actually don't find anything interesting in that. If you want to tell anything, because many of you are more educated than me, so let us discuss this thing. What is the difference between a fuel base? Just take an example of coal. So, what is the difference? Anybody? No. Please. Okay. Okay. Madam Garima Dwivedi, are you able to hear me from Bijnor? Am I audible? Am I audible?
Am I audible? Yes, sir.
Okay. Dr. U. Sujima
Okay,
Kumari.
Dr. U. Sujima.
No, I don't think that people are there, because it is happening in our country. Many of the cases I've seen that people they have started the solar, this.
Yes, sir. I'm Sujana.
Okay, madam, can we discuss this thing? What is the difference between the fuel-based electricity generation and the technology-based generation?
Sir,
Yeah,
please repeat, sir.
you can see on your screen as well. What is the difference between a fuel-based electricity generation and technology-based electricity generation?
Yes, sir, it's visible, sir.
So can you answer?
Fuel-based electricity mean it is from coal or from renewable energy sources like that, sir.
Yes, very good,
Technology-based means somewhat like solar panels like that, sir.
very good. So what is the difference in these two?
Sir, one will, if we use renewable sources, they may be exhausted, sir. Whereas if we use solar cells, the solar energy is unlimited, sir. So it will be long lasting, sir.
That is very good.
Thank you, sir. Thank you. Thank you, sir.
The basic, yeah, thank you, ma'am. So fuel based
Thank you.
generation, if you see the most important thing in fuel based generation is, if you demand more, the electricity, the fuel prices will go up. Okay, because we are all academic people, we understand the theoretical part, the academic part of any of the knowledge, but the most important part of anything is the commercial aspect of this technology. Okay, so if you see the fuel-based generation, you can go Coal India website and you can check present a price of coal. Okay, that is it is somewhere around 6 to 7 rupees per kg for a good quality coal. Okay, and if you demand more coal, the cost will go up. That is most important thing to understand. Okay, you can remember the prices 10 years back or 20 years back of the petrol and diesels. Now what is the price now? What we are paying? Okay, so if you demand more energy, the fuel prices will go up. But in this case, in technology based, when you demand more electricity from renewables, what will happen in that case? The prices of the technology will go down and there is no fuel. So fuel cost is zero and it is constant, and the prices of the technology will go down. So this is the most important thing to understand before going for any of the business or any of the training program. Okay, as you will demand more solar, more electricity, and if the source is solar and you are demanding every day more electricity, then the prices of the solar technology will go down. And we have seen this thing in last 10 years. I have seen, I can say that the first plant what I have installed in 2007, the prices was somewhere around 4 times than what we are actually installing today. And today the prices of electricity and the generated by solar photovoltaic and the plant cost, both are very less now. So either you are in capex or in the resco, either you are selling a solar plant or selling electricity, both are now least in terms of levelized cost of energy. You compare with any of the source of power, solar is lowest in terms of cost of power generation. So this is the major thing behind the success of solar photovoltaic. If you see the coal based power plant, it is not only the CO2 what you are emitting on the in the atmosphere. You have SOx and NOx gases which are very dangerous, and you need huge amount of oil, you need huge amount of water to generate the electricity, which we never count this thing. Okay, if I give you an idea about per unit coal requirement, so to generate 1 unit of electricity, we need 400 to 600 grams of coal, good quality coal, 400 to 600 grams. Now, if I go with the requirement of the water, So what per unit generation we need 7 liters of water. If I'm generating 1 unit of electricity, I need 7 liter of water. Either in the there are many losses because there is a huge catchment area of the water we are feeding into the boiler. It is cleaning process is there. So it is very important to understand what we are actually doing when we are generating power from the coal-based power plant. So this is a very good slide you can take for the reference. Now, how we are consuming, this is very important to understand. In our country, as I am doing some of the site survey on behalf of Indian Railway these days, Indian Railway is now coming up with installed capacity of 5 gigawatts. Okay, and that is something huge. And they have done many experiments like they are generally running on single phase 25 kV. So they are doing some experiments that how they can feed the power directly into traction substation at 25 kV. So and single phase. So this is in solar, all the departments, all the big consumers. If you consider here, so they have you if you take a 1% of this value, so it will be somewhere around one yeah, I think 11 terawatt hours. Okay, so 11 terawatt hours is the consumption of Indian Railway. They have to install a solar plant. So if I go with some small calculations, it will be a requirement of somewhere around 7 to 8 gigawatt of solar plants. So they have come up a size of 5 gigawatt, and now they are installing and they are doing some tendering process. And another 2 months, you will get the tender, and it's a huge investment from Indian Railway, and they have enough land along the track as well as they have a colonies like that. So you have to understand that we are consuming huge amount of power. It's a old figure today. If you ask me about 2019 to 2018, so 18 to 19, 2018 से 19 के बीच में how much we have consumed, it will be somewhere around 1200 to 1300 terawatt hours, including all independent power producers. So it is not only important to know about the installed capacity of our country, the most important thing is to understand how much electricity we are consuming. Here you can see the domestic is 24% and the demand is increasing by 5% in domestic, 8% in industry. So your demand is increasing day by day. You have to be very careful about the e-vehicles because we are expecting by 2030 we are expecting 80% the light utility vehicle, or you can say the small vehicles will be from electrically powered or fuel cell based the vehicles. So there will be a huge demand in coming days, and how we will generate. If you will go with the coal-based power plant, the traditional one, there will be huge problem of pollution as well as you need coal which is not available in our country. Although we are having a huge amount of coal reserve, but the quality of coal is not that good. So our import is you know far more than what we are actually producing at our country. So we have to go with some of the alternatives for upcoming demand. So I have estimated this thing that in next, you know, after 5 years, if you see what will be the demand of electric vehicles, so it is, there is a calculation for that, and it is somewhere around uh, if I go with the installed capacity of solar, so it will be a 50 gigawatt extra solar plants for meeting the demand of the electric vehicles. And we have two wheelers, we have three wheelers now, we are having four wheelers, and our entire traction is on the basis of this electrical power only. So if you see the Sankey diagram, I'm not going into the depth of this, but there is a huge TND losses in normal course of power utilization. So I'm not going into the depth, but let me give you an idea about the solar photovoltaic because anybody can ask you this thing to generate or to manufacture a solar module. Actually, you need a power. Okay, and if I need a power, how much power is required to manufacture a solar module? कि लोग ऐसा बोलते हैं कि आपका सोलर मॉड्यूल बनाने के लिए आपने ग्रिड से पावर लिया है सो व्हाट इज द आंसर फॉर दैट बिकॉज यू आर द पीपल हु आर फ्रॉम द colleges you must be able to answer these type of silly questions I would say because if I go with the study the carbon dioxide emission is least for solar photovoltaic and the generation cost of generation of electricity if you see it is now least in comparison with all. Now, the most interesting thing for for the people like you that the solar photovoltaic panel energy payback is only 1 week. Okay, so जितना बिजली उसको बनाने में लगा है, how much it has already consumed, it will generate within a week. Okay, so I have taken a example of 300 watt solar module, and there is a complete study for this, and you can go and you can Google as well. So right from the ingot and then the entire cell manufacturing, then the module manufacturing, and I have considered all the things in this, and I have found that only 1 week my solar module will have the buyback or energy payback, and it is very important to know. Otherwise, people will say that "ये बनाते समय तो grid का बिजली ले लिया" and like that. So this is very important to understand that the life is 25 years. After 1 week, you have a huge time for this. Okay. Solar photovoltaic is having a highest potential, and if you see the that is 68%, and it is estimated in 2019. There is a report from MNRE that if you compare all these things, the solar photovoltaic is the most convincing technology, and the cost of production is very less. And if you see the state-wise, as the potential what we are having is like this. So, because in Rajasthan we have a very good insulations of sunlight, we have a better production. I think you all are aware about the thing that this solar is having a different pattern of generation as it is depending upon the weather conditions. If you have a good weather, supporting weather for solar photovoltaic, you will get a better output. Let's take an example. You are installing a solar plant in Gujarat, and if you are installing a solar plant in Germany, there is a huge difference. Okay, in Gujarat, you will get a specific yield of somewhere around 1500 units of electricity. That means per kilowatt, you will generate in 1 year 1500 units of electricity per kilowatt. But if you go with countries like Germany, you will get the best of them are somewhere around 800 to 1000 units per kilowatt. If you say this, that is known as specific yield. So if I go with some countries like Namibia or some of the equator close to equator places like Togo, so they have a very good insulations. Nigeria is also having a very good insulation. So if I install these plants over there, the specific yield will be 1700 to 1800 units. If I'm generating electricity, that means my payback is faster. Okay, my investment will be, if I consider the return on investment on my entire plant, it will be very fast. So the potential is estimated on the basis of land available, the wasteland available, and the energy requirement. So if you see this Rajasthan, they have a huge amount of land and they have a good infrastructure for solar photovoltaic, and the transmission of the power also they can do. So there are many aspects in this. Andhra Pradesh, the Karnataka, they are also leader in this, and in Gujarat, we know about this thing. So they have initiated the thing. Global renewable energy employment. Okay, so if you see the solar photovoltaic, it is also a leader. So the highest amount of employment is, generated by you know this technology, solar photovoltaic. So you can say that this is one of the most convincing. Let me give you an idea about the investment of our target. Okay, I think you have already done this thing, that we have a target of rooftop of 40 gigawatt and the solar parks 20 entrepreneurs, and ongoing projects are around 20 gigawatt. So it's 100 gigawatt target set by government of India, but I don't want to be, read this type of things. Okay, आपको जब बोला जाता है कि 100 गीगावाट का टारगेट है, that is not a big thing. Okay, because वो बहुत ज्यादा significant लगता नहीं है. If I told you that this is an investment of 4 lakh crores, 4 लाख करोड़ का इन्वेस्टमेंट है, तब वो जरा कान खड़े हो जाते हैं कि 4 लाख करोड़ का इन्वेस्टमेंट अगर होने वाला है. यू कैन सी हियर, I have calculated this thing for you. If you understand the dollar terminology, this is that, this is the investment. Okay, just because of that, all the banks, the financial institutes, all the companies, you name any, Tata, the TVS, Hero Group, Adani, you name any of the group, okay, they have their solar division now. Okay, so it's a good employment opportunity and very good business opportunity. Okay, because it's a target. And do you know what is the potential of our country? If I replace only 10%, if I replace only 10% of our energy demand, that is 140 terawatt hours. Okay, and 140 terawatt hours you can generate with the help of 100 gigawatt solar plant, that you can calculate. Now, 100 gigawatt is only for 10% of my electricity demand. You can imagine what will be the increase in our demand in next 5 years. Okay, because electric vehicles are coming, our day by day production is increasing. Yes, due to this COVID, last six months, or you can say just slowdown of this thing, our demand is a little bit, now you can say at a saturation point we are having. But still, if I want to replace this entire solar, the entire coal-based power plant with the solar-based power plant, uh, uh, it is a potential of somewhere around 1,000 gigawatt solar plant. मतलब जितना हमने सेट किया उससे 10 गुना बिजनेस पोटेंशियल है. मतलब 4 लाख करोड़ के मुकाबले 40 लाख करोड़ का इन्वेस्टमेंट हो सकता है. एंड इट इज अ ह्यूज अमाउंट. एंड आप में से कुछ लोग बोल सकते हैं कि नहीं, व्हाट विल हैपन एट नाइट. ओके, सो दिस इज अ biggest revolution what we are now going to see in next 2 3 years is grid, grid level energy storage. Now this is uh, it is not a rocket science now. It is on there. Even in India, you are having a 1 megawatt hour storage. You can go and see in Andaman Nicobar, and there are many projects going on. So in Ladakh as well now, grid level storage. So grid level storage and solar photovoltaic, plus renewable energy and assisted by the hydropower plants as well as base load station of coal-based power plant, whatever we are having today is the future. Solar PV plus the grid level storage and the rest of the source of power as per their the availability of fuel and other things is the future. So it's a huge amount of, and globally we are expecting 3,200 in next 20 years. That is, with the stated policy what we are having. If we go with the sustainable development, it will be somewhere around 4,000 to 5,000 gigawatt solar plants in next 20 years. So it's a good business opportunity for everybody. I think you have covered this thing. What is the carbon sequestration from this? बट मैं आपको एक छोटा एग्जांपल देके बोलता हूँ कि अगर आपसे कोई बोले कि 1 किलोवाट का सोलर प्लांट लगाया है तो वो 1 किलोवाट सोलर प्लांट इज इक्वल टू 12 ट्रीज प्लांटिंग 12 बिग ट्रीज ओके आपने 1 किलोवाट का सोलर प्लांट अपनी छत में लगाया दैट मीन्स आपने 12 बड़े बड़े ट्रीज लगा दिए अपने छत के ऊपर ठीक है इतना आपने कार्बन के लिए आपका कंट्रीब्यूशन होता है so if somebody is installing 100 kilowatt or 500 kilowatt they are actually contributing in terms of carbon reduction whatever their footprints are it's a complete study what I have done for you you can go through it yes the prices are now at 2.44 recently it is 2.43 lowest ever there is a bid so the prices are very less now and if you go with the places like in India we are having around insulation like this so the levelized cost is lowest in solar photovoltaic you can compare with any of the latest technology what we are having for power generation okay the cost of the installation here in India as well is very less for rooftop mainly so if you see the cost of the installation and for the commercial and residential, we comes at the the what you can say the most economical installation what we can do here in India. Now let me conclude the the advantages. I think you all are aware about this thing. Okay, somebody was asking that I should continue with English. Okay, that's okay. Uh, I would be happier that if you will be able to understand in English as well. Okay, thank you. Let's go further. It's a reliable solution, bankable, fast to install, enhanced power quality, good return on investment, easy to maintain, and if you have a renewable purchase obligation, so all the discoms are having RPO. That's why they are installing a solar generation meter over there. Okay, what are the top 10 states in our country? If you compare the things, so the Maharashtra is at on top because they are having the highest tariff rates. Just because of that, the viability of the solar power plants is very good, and this is the entire thing. So if a top 10 solar state with the cumulative installation is the top one is the Karnataka. 24%. Telangana and United Andhra Pradesh, if you see the Andhra plus Telangana, they are, I think, number one. They have a very good policy. I have started the DISCOM training program on behalf of USAID 3 years back, and I have a very good experience with Andhra Pradesh DISCOM. We have a general manager, and fortunately, it's a lady who is leading the entire thing. So, have an entire department in distribution company office that there is an entire solar dedicated solar division, and GM Solar is a post in this. In Andhra Pradesh. So they have a very good infrastructure. They have a very good way of settling the the power what somebody is evacuating. But recently there was some government change, and this is the very important aspect that we should understand. In our country, there is a flip flop, okay, of policies, which is very very important to understand, because there may be a possibility that there is new government which is coming, they can change the entire rules. It happened in our Madhya Pradesh as well. In my place, when the the know, they were not able to do this thing properly. Okay. Now, if you see the is like this. So this is the job of the Ministry of New and Renewable Energy, users to understand what is the real cost, and special it is around 42 rupees for per watt cost, and if after this cost, this is the benchmark price. There will be a tender, and the discoms will float the tender in upcoming days, and this 42 rupees will again revise, and presently in Madhya Pradesh it is around 37 rupees for the residential users, and there is a subsidy as well for that. Now let me give you an idea about the incentives. Okay, so we have a generation-based incentives in few states. Like if you take an example of Haryana and Delhi, so they provide rebates on tariff for solar energy consumed. Then the building norms. So few states relax the building norms with the rooftop solar photovoltaic projects. Allow higher floor area ratio, so you need not to take any permission from a municipal corporation to install elevated solar plants. And the subsidies are from 20 to 40% of capital cost, on benchmark price of the set by the MNRE for residential consumers. Now, for commercial consumers, it is not there now. And the depreciation benefits for the commercial consumers, like companies, those who are installing a solar plant under the CAPEX or RESCO model. So 40% depreciation allowed. That is the the key success, you can say, criteria or the incentive for the investor, for any of the company, those who are coming in the solar area. Renewable purchase obligation is on on discoms. So for non-solar, it is for the fiscal year of 20, it's 10.25, for solar 7.25. So whatever amount of electricity is consuming in your state, 7.25% should come from the solar only. So this is the target for fiscal year 20, and if you see, it is increasing day by day, year by year. And if you see, only 6 out of 29 states are able to meet this. As you can see, that everywhere we are having installations on rooftop or solar parks are coming, but the discoms are not able to this me meet the target what they have actually set by the government. So Gujarat, Madhya Pradesh, Maharashtra, Chhattisgarh, Tamil Nadu, Goa, Punjab, Delhi. So they are among top laggards. And if you see the small states like Nagaland, Meghalaya are meeting or exceeding the targets. So because they have a very less demand and they are purchasing renewable energy certificates. So this is another way to meet the RPO. I think it is already explained in some of the slides. Uh, okay, let me give you an idea about the Amenari Phase 2. In this additional rooftop solar photovoltaic capacity of 38,000 megawatt plant will come. And this is important to understand this thing that the 4,000 megawatt will go to the residential consumer, in which first 3 kilowatt will get 40% this uh, the subsidy on benchmark price. First 3 kilowatt. If somebody is installing bigger than 3 kilowatt, 4 to 10, he will get 20%. So this is the way now we are having central financial assistance, and this is very good for the residential consumer. If somebody is having a Griha Housing Society and Residential Welfare Association, up to 500 kilowatt they can go, and 20% will be the subsidy from the central government. If there is any subsidy available from your state, you can add this thing, and the prices will go further down. But here there is a clause that it should not go per house more than 10 kilowatt if there is a clear house of society or something like that. Now there is a component B in which for other sectors is 34,000 megawatt target, and the incentive to the for initial 18,000 megawatt peak. So here in MNRE phase 2, discoms are at forefront as a key driver, and the domestic manufactured solar cell, and it's a DCR. I think you have already discussed in some of the session that domestic content required. There is a criteria now that all the solar modules should be manufactured in our country, and whatever they are using for the manufacturing a solar module, it should come from our local industries, or you can say it should be manufactured in India, manufactured by any of the company, any of the multinational, but it should be manufactured in our country. So incentives are now there for the discoms to meet or to what do you say, the compensate their loss what they will make in upcoming days. But if somebody will ask, tell you from any of the discount company, I am going to lose my good consumers, I am going to lose my money. It is not like that. They don't need to purchase from the generation company. Na? Only thing what they are doing is they are first purchasing from the generation company and they are distributing to the consumers. Unfortunately, in our country, we have some, the cross subsidies for agricultural users, for the residential users. For some places, we have a relaxation for industries as well. So, if you go and see in Japan, the things are almost reverse. Okay, the costliest electricity in Japan is residential electricity. Cheapest is industrial and commercial (INC). In our country, the highest amount of the money, the consumers coming from the commercial and have to pay the highest amount of electricity bills. Although they are actually contributing, they are manufacturing something, they are selling something, they have the very good establishments, and they have to pay more. It's unfortunate, but it is happening here in India. I don't know when we will change this thing, or we can change or not. I don't have any idea about this thing, but it should change. because the residential electricity we are subsidizing all the time, and we are actually making our electricity boards bankrupt. Read somewhere that MP electricity board was taking loans to pay the loans, okay, from LIC, from life insurance company, corporation. What we are having, they are taking some loans, and for paying the loans back the EMI or something, they are again taking some loans. So this is pathetic. So we have to make our companies profitable, and electricity is not free. If we are wasting our money in the subsidizing the electricity, that is something not good for the the industry and the our country's progress. Okay, so the responsibility of the discom will be there, and they will create a the RTS cell, the rooftop solar cell, and there will be a division head, and it will be in next 5-6 months you will see these things in the entire country. So now let me go a little bit fast. This entire project will be monitored by the MNRE, and MNRE will as well. You can spin portal the entire project. What if somebody has taken a commission of the has to feed the entire data the latitude, the install capacity, name and contact detail of the developer, project cost, and it should be uploaded by the discom on the portal. And there is another unified web portal is coming, and with Arms and Ang, we are doing this thing, and we are developing some training for the discoms as well. Ministry has also initiated a process of geotagging of these projects with the assistance of space organization, and what happening. Now, let me ask you one important question that you should remember at least after this training program. That if bidirectional meter is not installed and solar PV plant exports the electricity into the grid, what will happen? Choose the right one. First case, export unit will not count, and distributed generator, that is solar photovoltaic plant, will not get any credit for exported units. Okay. Case 2, due to export unidirectional meter which is there in your house or in your college will burn. Okay, and metering will stop. Third, exported unit will count as an import of electricity, and DG has to pay at the same tariff even for export. Okay, now which one is correct? Anybody has any idea? What will happen in that case? Anybody has any idea?
Case
Huh?
1.
Case 1, export unit will not count. Okay. Arpita Rakshita, case 1. No, unfortunately, you have not read the things. Case 2, Mr. Mohammad Karmid Khan, case 2. No. Nisha Soni, case 2 is also not the right answer. Case 3 is the right answer. Export unit, whatever. Yes, Guna Kagaran, yes, 3. Okay. So, case 3 is right. When you will export the electricity, and if you don't have a bidirectional meter, the exported unit will count as an import, and you have to pay for that. That is the important thing you should understand before going for on-grid solar plants. Okay, if it is an on-grid solar plant, you have to pay if you are exporting, because unidirectional meter will count as a one unit exported as an import, because counting importing. It does not matter current is going from load to utility or utility to load. It will count 1. If there is a 1 kilowatt for 1 hour, it will count 1. That is 1 unit of electricity. So you have to be very careful, you have to be very clear about this thing, that if you will export without having any of the metering arrangements, okay, that is, gross metering, you have the exported unit for the net metering. Sorry, for the gross metering, it is not there. For the gross metering, entire electricity you are whatever you are producing, you are actually exporting into the grid. So you have to be very careful about this thing while teaching or while any kind of tendering. You should understand that you have to go first for feasibility analysis from the discom, and when you have approvals from the discom, then only you should install the solar plants. Otherwise not. You cannot initiate your solar plant without having a consent from the discom. You have to inform that I am going to install this size of the solar plant, this is my size of the solar plant. If they permits you, there are many criteria we will discuss in upcoming slides, and then you can start the installation work. And after the installation, they will come for the joint inspection and they will give you the permission. So this is very important. The regulation now starts actually. Okay. So what I can do if I don't have any of the opportunity to export the electricity? So just take an example of Uttar Pradesh. Now they are having net metering policy only for the residential consumers. But it is really unfortunate to have a policy like this. But the technical people have solution for everything, like zero export. Okay? If you see this thing here, what will happen? You can go for a solar plant and you install a zero export device. It will never allow electricity to go back into the grid. Okay, zero export solutions are now inbuilt in the inverters. Like presently, I am installing a 70 kilowatt inverter here in Daman, and I have somewhere around 2 megawatt installation in Daman now. So in this 70 kilowatt, my delta inverter, I have zero export facility inbuilt, and there are many features now in inverters readily available. So you need not to worry about the things. If there is no policy like this, you can go for the zero export. And the second important thing, what I would like to add now is the partial or controlled export. Okay, this is another very good feature now. What we are having in the solar inverters is the partial or controlled export. So what can we do? Like if I'm installing a 100 kilowatt plant, I can restrict the export at 50 kilowatt. I think I'm very much clear that I have installed a 100 kilowatt plant which can export 100 kilowatt, but I can restrict 75, 70, 60, 40, 10 or 0. It is my choice. I can do programming, I can do some kind of setting changes, and it will done with the help of inverter only. Now inverters are very sophisticated. This is known as partial or controlled export. Now what it can give you, okay, if you see the prima facie, it will look, oh my god, you are wasting my electricity. I have electricity to export, but you are not giving me an opportunity to export. Now let me give you one thing, the most important thing. 33 kV consumers are having bidirectional meters. Okay, they can export the electricity. Just take an example of Aligarh Muslim University, AMU. They are exporting the electricity, they are not getting any benefit out of it, but they are not penalizing as well. Okay, because they have a bidirectional metering. So whatever export they are having, they are not getting any credit or any money out of it. They can claim as per the Electricity Regulatory Commission Act, in the Electricity Act 2003, and there are many things that they can claim at least APPC, average purchase pool cost. They can claim. They can go directly to the CERC and or SERC, State Electricity Regulatory Commission or Central Electricity Regulatory Commission, and there is a code, and 100% they will get at least APPC, average, because after 2003 we have an act that anybody can become independent power producer. Okay, IPP. This is very important. Now, in this partial or controlled export, what you can do here, I can install a bigger power plant than the limits set by the discoms. There are certain limits. What seen in the last presentation, last to last presentation, there are certain limits like 40% you can go with the distribution transformer capacity, or 100% of your contract demand, or 80% of your contract demand, or 50% of the contract demand. State wise, it is changing. Every state is having their own policy. If you go with the Gujarat, they have a DDR capacity of 60%. So if you have a distribution transformer of say 100 kVA, you cannot go beyond 60 kVA solar plant, or 60 kVA power exported by the solar plant. So their intention is to restrict more power than 60 kVA into the electrical network. Why they are looking at like this? Because they don't want to imbalance in the grid. Okay, they don't want any kind of imbalance in phase, any kind of harmonics more than 4%, and any of the DC injection from the solar plant, like that. So there are certain things to understand the power quality and all. So they restrict the solar power plants to up to certain level. But have a partial or controlled export, what I can go? I can go with the bigger power plant and I can restrict the export at this level, but whatever I will consume, that will be my benefit. Now, which is latest. See here, this is a the implementation process in which you start from this, and first is your site assessment and planning, physical and electrical survey. Then the system designing will be there, and the system approvals. You have to go with the discoms. In the system designing, you have to consider the shadow free area available. I think you all know about this thing, that per kilowatt you need 8 meters square or 800 square feet area. Now, with the 17% efficient solar modules. So, DTR capacity, then there will be energy bill analysis, and then you will go with for the system approvals. So, this DISCOM, your distribution company, your electricity board, will come for the assessment that what you are asking is as per your demand. So you cannot go beyond your demand. If you have taken a demand of 5 kilowatt, you cannot go beyond this. Okay. If you have a demand of 2 megawatt, you cannot go beyond 2 megawatt of solar power plants in the industry. Here, then after having these approvals, you go for the system installation. Then joint inspection. If you have a complete commissioning, then there will be a joint inspection with the distribution company, and the and connection permission you will get, and there will be installation of bidirectional meter. Then the performance assurance, the performance ratio, the capacity utilization factor, the ground coverage ratio, the specific yield, things will come into the picture, and there are many things like P50, P90 analysis of if somebody wants to go for the finance, these type of things are come into the picture. Okay, let me go for roles and responsibility of a grid engineer. They receive the document from you. They test pre-commissioning and post-commissioning. They check. Unfortunately, in India, nobody do this thing. Only the installer and the EPC company, they do entire thing like the commissioning and testing. The solar PV, The basic technology is architecture they know, and they see the number of modules, number of inverters, and check, and they give you a permission of interconnection to install and they install a net meter. They verify the plant capacity and upload the document in portal. So, why the rules and regulations are required? Because now you are connecting your solar power plant with the national grid. So you have to follow the norms of frequency, norms of voltage, frequency fluctuation. You have to be very careful about the phase sequence, the waveform, the harmonics, DC injection, the flicker. There are many power quality aspects, and you have to be very much careful about this thing before going for the grid connected solar plant. Because of that, there is a need of the regulations and the policy. Now, the applicable standards and the regulation for the grid connectivity is, the Central Electricity Authority, the technical standard for the connectivity of distributed generation resources, Regulation 2013. You can download this thing; it is available. IEEE 1547. This is a backbone for the power quality. So, standard for interconnected distributed resources with the electric power system 2003. CA measuring related, measures related to safety and electric supply, Regulation 2010. Regulation 2007, technical standard for connectivity of to the grid, and IEEE 519. So this is highly important in terms of harmonics, and 2014 is the latest. I think there is another revision now for IEEE 519. You have to check for that. Now the department responsible for this is CA, CERC, and the Bureau of Indian Standards. International organizations like IEC is also there, so they give the standards like IS 61215 for solar modules, mainly for the crystalline solar modules, and the BIS norms, IEEE norms, IEC norms are there. So if you want to install a meter, so there are guidelines from the state of the Central Electricity Regulatory Commission. So generic tariff order of 2013. So you have to check. There may be a revision for your state. So how you will do the tariff? Okay, how you will do the billing, or how you will just take an example. The prices of electricity is something different. If you go for Uttar Pradesh, the prices are different. If you see the diesel prices are least, I think I have traveled recently. The diesel prices are 74 rupees, but if you come into Maharashtra, it is 79 rupees. If you go for Madhya Pradesh, it is around 80 rupees. So there is a difference just because of the policies. Like that in electricity as well, all the state regulatory commissions are do their own tariff planning. So they can have different tariffs for residential, different tariff for industries, different tariff for the commercial consumers. So in some of the places, the agricultural users are having free of the cost of electricity, like Telangana. Agricultural feeder is 100% free. If you go to Telangana, agricultural feeder is free. There is no electricity bill, even for no fixed charges as well for the pumping. So these are the things, and it varies as per the state revenue available, and how much they are obliging their farmers, or I don't know why it is there, but yes, it is. There is a difference in all the states in our country. Okay, now these are the very important criteria, like the metering mechanism. Either you are having a net metering or gross metering policy. So you have to be very careful while choosing this type of metering arrangements. Eligible consumers, project capacity, aggregate capacity. So the project capacity is limited by the maximum, as per the guidelines given by the your state regulatory electricity regulatory commission. You cannot go beyond your contract demand like that. Maybe 80%, maybe 70%. So you have to check with your guidelines. Your solar policy you can download and you will get all the information related with this. Connection levels. What is the voltage level you have to connect? Excess generation if you will have. Quantum of excess generation allowed and the settlement of excess generation. So how much time it will take the settlement period? 6 months, it may be 1 year. So there are three in general 6 months and 1 year. So most of it is 6 months, and very few cases you have 1 month. Every month you have a settlement. If you have a surplus power, they will give you whatever the average cost of supply is there. They will give you the this money for this export of the electricity. Now, renewable purchase obligation and the renewable energy certificate, I think it is already been covered with the some of the sessions, because renewable purchase obligation, I think you understand now. Okay, metering provisions, standards, accuracy level. So as you have a bigger power plants, you have to have high accuracy, as well as the accuracy class will change. There are certain norms for the meters as well, but there are some other charges like wheeling and banking, cross subsidy charges. Maybe if you are installing in the gross metering, there may be some different kind of charges. So the connected load is very important for sizing going for phase or 3 phase. Percentage of distribution transformer is very important. Predefined capacity. Maybe anybody would like to say something? Okay. Overall capping at state. Dr. Imtiaz Yusuf, would like to ask anything? No, I am not able to hear your voice. Bhaskar Avadia. Dr.
Ramananda question, sir.
Yeah. Can you wait? Can you wait for another 5 minutes? We will discuss
Okay.
after 10 minutes. We will discuss your questions. Thank you for your kind cooperation. Okay, so these are the the important criterias what we are having before going for any plant sizing. So just take an example of Odisha. Okay, in Odisha, yeah, there is a very interesting limit set by the OREDA. So what they are having, 90% of electricity consumption you can generate. You cannot go beyond 90% of your consumption. Got. So this is very simple. This thing. I have installed some of my power plants in Oman. It's a very simple guideline. Okay, you are consuming 1,000 of electricity. Okay, 1,000 is your total consumption per year. You can generate 1,000 per year, not more than that. If you will that, we will not give you any kind of incentives, or we will not pay for the extra amount of electricity what you will generate. So that is the way one can make a policy, okay, but in our country, all the states are having their own regulations, their own understanding of solar power plants and all. Unfortunately, there is no uniform thing, and I don't think there should be one uniform thing. All the states are having their own problems, challenges. Some of them are very rich in terms of coal, some of them are not having. So definitely they will have some differences, but we can simplify further. I think you all people are very influencing people, like you are all professors. So you can ask this thing, because the percentage size of the distribution transformer does not, the loading on the transformer is important. Okay, how much it is loaded. In most of the places in Uttar Pradesh, I have seen all the transformers are at least 150% loaded. That means they are overloaded all the time. Okay, in peak hours, they are 200 times overloaded. There are many losses associated with these type of things. Okay, so if somebody is having a study of loading of transformers, that is more than the size of the transformer. Because if you are exporting or importing from the transformer, it does not affect the transformer, the efficiency as well as the transformer life. Okay, if you are installing a solar power plant, you are unloading the transformer. It will increase the size, increase the life of the transformers, and it will increase the the quality of the power as well, because solar power plants are having a very good quality of power if it is having a balanced system in terms of load as well as the power generation. There is some challenges. There are certain challenges, like in your just level of any university, they have a load of somewhere around 100 kilowatt on R phase, 100 kilowatt on Y phase, 100 kilowatt on B phase. R, Y, B, they are having a balanced load. Then if you have a 100 kilowatt system or 300 kilowatt solar plant, it will balance the thing. But unfortunately, you are not running, because at the time of connection, you know, guidelines. Okay, you have to have a balanced load. But unfortunately, we cannot run all the loads simultaneously. एक साथ तो नहीं चालू करेंगे. We cannot put the entire load. It may be a possibility that some of the departments are consuming more due to some experiments or all something. So there is always a fluctuation in the load demand. Is because of that there is a fluctuation in the power quality in terms of harmonics and the flicker. Now, if you have this thing, you have to have some, if you have a big installations like a university or a big colleges, you can go for the power quality boosters like a capacitor bank, or there are some series reactors. There are many things which can give you very good quality power. So this is actually required to study, and I think Bombay IIT have done a study for this. But I would say that if you have any contact in you and all, you can say that the size does not matter, because it is working on mutual induction. Okay, so the solar plant, if it is a bigger size or smaller size, then the capacity, it does not matter. How much your transformer is loaded, whether it is at 100% load or 80% load or 200% load. If it is 200% load, you can allow 200% of solar plants, but you have to go with some study. And on behalf of these distribution companies, the educational institutes can do some study and research work. Okay, let me go further. Connected voltage, 3 kilowatt, more than 3 kilowatt, yes, you can go with 3 phase for the better performance. Compensation, few states provide average pool purchase cost. Karnataka, Rajasthan provides higher tariff 7.20, and some states do not provide, does not provide any of the compensation for this. A standard and the certifications, most of the states follow the standards and the certification allowed by the Ministry of Renewable Energy, MNRE. Few states recommended their own standards and the certification. Okay. IEEE 519 CEA Regulation 2013 states that synchronization voltage fluctuation should not go plus minus 5%, and minimum observation time is 60 seconds, like this, and 80 to 110% nominal connected this thing is there. RTSPV shall not create transient voltage variation in point of connection of more than 3% rated voltage. So these are some guidelines for the voltage fluctuation. So these are the regulation. Okay. So unfortunately in India, there is no auditor for the solar power plants, but in future it will definitely happen, at least for the rooftop solar plants. If they are not fulfilling these type of standards like IEC 61727 and IEEE 519, those are giving you this thing. Nowadays the inverters are taking care of this thing. Okay, if there is a fluctuation in the voltage, inverter will get tripped. This is a huge problem in our country. If you will install a solar power plant in Gujarat, you have to reduce the voltage limits. And if you are installing a solar plant in Bihar or Uttar Pradesh, you have to increase the voltage limits of solar inverters. So there are two standards. If you go for the delta inverters, they have clearly mentioned India and India standard. So for the India standard, yes, for the lower voltage level places, they even set the grid code of India as STD. And for some of the places where you are having a very good level of voltage, you can go with there is another setting for that. So inverters are taking care of this thing. So if there is any fluctuation of the voltage, inverter will get tripped, and unfortunately it will reduce the power generation. Okay, the frequency, okay, should not go beyond 50.5, and 47 cannot go below 47.5 frequency. Clearing time is 0.2 seconds. Flicker 61000, I think you all are aware about what is flicker. If there is a flicker, the power quality will reduce. Harmonics should not go beyond 5%. So maximum total harmonic distortion current is less than or equal to 5%, and not more than 50% rated inverter output. So this is something challenging. Okay, you can see all the inverters, if they are under generation is very less. Like if you have a 10% generation, just because of the insulation is less, the harmonics are more. So to mitigate these harmonics, and you have to have some filters, some extra filters, if you have a big power plant. So there are many things you can do, but unfortunately in India, nobody bothers about the power quality in most of the cases because we have some sensitive equipments. But if you have some sensitive equipments in your place and you need a good quality power, then you have to be very careful about the harmonics. Most probably in the hospitals where you are having a very good quality equipments. Okay, there are some other parameters. I'm not going much into that, but yes, for the earthing, you have to follow IS 30431986. DC injection should not go beyond 0.5% of rated output. So that this is the limit. Power factor 0.85, 0.9, and I think you all are aware about the reactive and active power. Yes, so these are the regulation which is there. So if you have complete, the assessment from the DISCOM, and then you can go for the installation, and you have to submit this type of documents like single line diagram, plant earthing layout, like this. This is your single line diagram. The actual diagram what we made is like this. Plant layout, how I am going to install a plant, and then I can go for the installation. After that, joint inspection hoga, and then for the joint inspection, they will come with a bidirectional meter and the test report, and they will install the bidirectional meter. So these are the some documents required at Daman, because Daman is a union territory, and you can go. You have to install a 5% of your consumption a solar plant. So this is very important to understand this thing. Okay. Unfortunately, in Daman today there is a huge rain. Just because of that, my internet is not that good. I'm really sorry for that, but yes, these are the things. There are certain tests. The most important thing is they will take the entire thing and they will upload the entire document in the spin portal of Ministry of New and Renewable Energy. There is no there is a dedicated unified web portal as well, and we have developed this thing with Ernst and Young, and yes, after some time the discoms will have a complete unified web portal for the solar photovoltaic plant. This I'm giving you this one link in which you can go and see how the private companies are working. Like that, all the now the government companies, distribution companies are also doing a complete online way of the informations. So grid protection, let me give you an idea about IEC 62116, in which there is a clause of anti-islanding. So if there is no reference power from the grid, the entire power plant will get shut. Okay. So for the on-grid power plants, if there is no reference from the grid, it will never export the electricity towards the grid. Okay. There is no conversion from DC to AC in inverter. Okay. So this is the further explanation of anti-islanding. If you see in the anti-island, time limit is 2 seconds. So before 2 seconds, it will disconnect. Okay, the disconnection time is generally 0.2 seconds, but in 2 seconds it will get de-energized, and if there is a reference available, another 60 seconds it will take and it will get started. So this is as per the guidelines of IEEE 1547, and this is highly important. And the isolator switch cannot be more than 2.44 meters because this is for the highest point of isolator should not be more than either the DC isolator or the AC isolator as per the guidelines. You can read this thing in all the policies, and it is as per the grid codes. Three types. One is AC earthing, AC side is your inverter, ACDB, and DC side is your solar modules, structures, and the VCDB. So you have to connect with the two dedicated AC and DC earthing, all the components, and there will be one dedicated earthing for lightning arrestor. So they have to follow either IS 3043 or IEC 62561-1-7. This is very important. Standard, you will get the standard operating procedure in any of the PWD guideline or something. So standard SOP is there for these earthings. Earthing is highly critical. If the things are like this, DISCOM people will, they will not allow you to do this thing. Even from the DISCOM, the will not give you any warranty if you drill like this. So earthing is highly critical for the equipment earthing, module earthing, and the structure earthing. If you have this thing, you will definitely have a better performance of the solar plant because it reduces the potential induced degradation. There are many things if you have a good earthing with you. 62305 IC for the lightning protection. If you have a lightning prone area, you have to be very careful for at least Maharashtra, some of the places in Bihar, some of the places in coastal areas where you have a lightning prone zones, where you have to go with some early streamer type. You can go, or you can go for the normal lightning arresters. So this is important. You should install at back side of the solar plant, not in front of the solar plant, at back side of the solar plant, so that it should not cast any kind of shadow on the plant. And there is a separation distance that is also important for the discom's perspective. You should not install बिल्कुल just लगा के नहीं रखना है इसको. You have to have some separation distance from the solar plants for the lighting arresters. Okay, CT based and the bidirectional meters are there. Okay, these are the components list, and there is a checklist for the discom engineers. They will come and they will check the entire thing like this, and they will do unintentional islanding functionality test. So if there is more than one inverter, test should be carried out for each inverter. Solar photovoltaic rooftop system should produce more than 20% when you are doing this type of test. So this is important test. I'm just mentioning there are many tests like this, but for at least for people like you remember this thing. 20% of the rated output is there, then you can go for the test. This test must be conducted during the noon time on the sunny day. What is the test? You just go in front of the inverter, you just stop the supply within 0.2 seconds, it will get shut. Okay, so DC supply from the solar photovoltaic array connected. You have to keep as like that, and place the voltage probe in the inverter side at the AC mains, and as you will turn off, the entire things will go down. So these are the steps, and then when you will restart within 60 seconds, it should get a start, and the steps are like this. So when you will disconnect the AC reference, it will get immediately stopped. When you will connect it, it will connect within 60 seconds. It will give you a time for synchronization with the grid. So if you have a reference available with a say 110 volts or 60 hertz, no, in India it says 220 volts and 50 hertz. So it will take around 60 seconds. In Australia, we have 2 minutes of time delay for this. So there are many grid codes in that. You have to study a lot for this. But unfortunately, in India, we have a right to disconnect with discoms. They are having a right to disconnect anytime if they have any emergency. They will disconnect your solar plant if they are doing any kind of maintenance, or if they don't want, just because of any reason, power quality or any reason, they can stop your power production immediately. So they have a right to disconnect. Many standards are also there like this. I'm giving you this thing. There is a link as well. You can go and read all the standards as well. Now, let me show you my last thing. Now, why these are required actually.
Shukla sir, we are running. We have 2-3 minutes. Thank you.
Yes, sir. I know. Okay, if we have less time, we can now stop. And if you have any doubt, we can discuss now. Yes, If anybody would like to discuss anything, you can come now. You please unmute yourself. Ask me. Yes, sir.
Sir, can you show the standards? Just the last two standards what we are discussing, the last two slides.
Okay. So let me share one more time. There are many standards in now. In BIS standard as well, but let's. Hmm. You want anything to ask in this?
Yeah, actually, sir,